Hey everyone, my name is Matheus, welcome back to the channel, and today I'm going to explain you the minimum window substring, a hard-level problem on LeetCode that frequently shows up on technical interviews, and by the end of the video, you'll understand it from scratch. So given two strings, S and T, we need to find the smallest part of S that contains all the letters of T. Looking at this, we need to find the smallest part of S that contains A, B, and C. The answer is going to be B, A, and C, 4 letters at the end of the string. But how do we get there efficiently? Okay, so now let's draw it to understand it better. The first step is going to be expanding. So we're going to move the right pointer until we find the 3 letters we need. So we're going to store the left pointer here on the letter A, and we're going to move it until we get here in the letter C. And in this case, we're going to store, which is going to be, at this moment, the smallest substring we found, which is going to be A, D, O, B, E, C. Okay, so the second step is going to be shrinking. We're going to try to reduce as much as we can the substring to find the smallest one. But when we do it, in this case, let's see what's going to happen. When we move the left pointer to the next index, we're going to get to the letter D. And then at this point, we won't have the 3 letters we needed. So we're going to go back to the first step. And at the first step, we're going to get to the letter A here. When we get to the letter A here, we're going to have the 3 letters we needed. We're going to have the B, C, and letter A. Okay? But it's not smaller than the first one we had. So we're going to step 2. We're going to shrink again. And we're going to move the left pointer we had. We're going to move the left pointer we had until the letter O. When we get to the letter O, we won't have the 3 letters anymore. So we're going to expand it again. And we're going to expand it again until we get to the letter C here again. When we get to the letter C here again, we will have B, A, and C, the 3 letters. But it won't be the smallest string. So we're going to step 2 one more time. We're going to shrink it until the pointer gets to the letter B, which in this case we're going to have letter B, letter A, and letter C. So we're going to replace the smallest substring we found, and we're going to store here, we're going to store here B, A, and C. Okay? But how are we going to manage all of these variables and substrings? I'm going to show you. Okay, so I have drawn here previously what we're going to need. In this case, we're going to use 2 hash maps. The first hash map is going to be called T hash, which is going to store all of the letters in T and how many times each one of them appears. And the second hash map is going to be called S hash. And we're going to use it to keep track of what we have found. Okay? So these 2 variables here, need and have, are going to be compared. So let me just give you an example. When A in T hash is equals 1, it means that the letter A in T shows up one time. And when we have the key A with the value 1 in the S hash, it means that we have found 1A in the substring. So it means they are equal. So one of the 3 we need is okay. So we're going to increase the have variable here to 1. And when we do it 3 times, so we have achieved the goal of finding the 3 letters, we're going to compare, and if they are equal, we're going to store the smallest substring. And when we expand, we're going to do this. If we find a letter, we're going to store specifically the letters that we need in T, okay? And when we shrink and we lose a letter, we're going to remove it. We're going to decrease the variable we have and is inside the hash map, and also the have variable. So now let's implement this in the code, okay? So let's see the code implementation. First of all, we're going to declare the hash maps, as I showed you guys. After that, we're going to populate the T hash map. This line here compares if this char is not in the hash map yet, we're going to set it to 0. And in this case, we're going to increase the variable, okay? So the value is going to be increased. After that, we're going to have a lot of control variables. The left and the right are going to be used to be the pointers. The have, I have showed you how it works. The need, I have also showed you how it works. So it's going to get the length only of the keys and not the full length, because we have repeated letters. It's not going to be counting. Okay. The len here in this case is going to be the length of the current smallest substring, and the rest left is going to be the response left pointer. We're going to use it at the end. I'm going to show you how it works. So this is the main loop here. This while giant loop here is going to be expanding the window. Okay, so it's going to expand until the right while right is smaller than s.length. Okay, so we're going to be putting the values inside of the s hash map, and we're going to compare here if the value we are currently working with is in the t hash map, and it's also equal in the s hash map and the t hash map. So if the value is equal, we're going to increase the have variable. So while have is equal to need is going to be the shrinking process. So we have expanded until we get to a point which we have a big window with the 3 letters, or as many letters the problem gives us. But in this case we're going to play with 3, as I have showed you here. So while they are equal, have and need, we are going to shrink the window to try to find the smallest one. Okay, so if right minus left plus 1 is less than the smallest one we had, so if the window is smaller than the smallest one, we're going to replace the values. Okay, so the new length is going to be right minus left plus 1, and the point where we're going to start is going to be the response left, in this moment is going to be equals to the left pointer. Okay, I'm going to show you in the end how we're going to use this variable. We're going to decrease because we are shrinking, so each time we move the left pointer we need to decrease in the hash map how many times we have seen that letter. And if at one point the letter in the s hash map has a different value than the t hash map, in this case if it's smaller, we're going to decrease the have variable, because it means that we do not have as many letters, as many occurrences of that letter that we need. So we're going to keep improving left. We're going to be increasing left in the smaller while loop, and the bigger while loop is going to be always increasing the right because it's expanding. Okay, so in the end we're going to return length. This is a different kind of if. I can show you properly in a different video. That's an important point here. Why have we started the length with infinity? Because we are going to get the smaller one. If we started it as 0, for example, we will never get it smaller than that, so we will never use the variable and it wouldn't work. Okay, so if the length is equal to infinity, it means that we have not used it. So let me see, for example, this case here, we're going to return empty, because we are not able to find 2 A's in a string that has 1 A. But in case it's not infinity, means we have used it, and we're going to return s, so the first string, and we're going to slice it starting in the response left, okay, plus the length that we need in that window. So now let's run. It's a JavaScript code. I'm sorry for not mentioning it before. Let me run it. Okay, it worked. So let's submit. Let's see. Yep, it worked. So that's all for today. It's a hard level problem, as I have told you. If you want to talk about any different topic, if you want me to solve any specific problem, you can text me in LinkedIn. I don't know, but I can leave my LinkedIn in the description of the video. And I think that's it. See you in the next video, guys.